All right, today's lesson deals with section 5.6, using inequalities to make comparisons in two triangles. In this section, we can talk about indirect proof, but I'm not going to be testing you on that, so we can actually skip this vocab box and go directly to the theorems that talk about inequalities. So these theorems are really important. This one is called the Hinge Theorem. And if you think of it, hinges are used on a door. Typically they're used on a door, and a door usually has an opening that's the same size. When you open the door, that increases this angle right here. This is the opening for the door. That's how far the door is swinging open. You could also shut the door. There's the opening, there's the door. And notice how the angle gets smaller and the opening over here gets smaller. This angle over here, that was the hinge. That's the hinge angle. So the process is this. Here's the concept. You compare the angle with its opposite side. Compare the angle with its opposite side. So the opposite side here is WX. The opposite side here is ST. Well, if these sides are the same on each triangle, but these angles vary. If this angle is bigger than that one, then you can say WX is greater than ST. So it's comparing to the side opposite. Similarly, I can compare these two over here. I have a side and the angle across from it. A side and the angle across from it. Well, which side is larger, the 9 or 12? Well, the 12 is definitely larger, so that means this angle will be larger than this angle. That means angle C will be greater than angle F, the hinge angle. Example 1 gets a little more challenging. It says, given that AD is congruent to BC, and it's marked like that, how does angle 1 compare to angle 2? So we're comparing angle 1 and angle 2. What you should remember about the hinge theorem is you examine the angle or the side across from it, opposite it. So angle 1 is across from 34, angle 2 is across from 33. Well, which side is larger, 33 or 34? So if 34 is larger, then angle 1 is greater than angle 2. Angle 1 is greater than the measure of angle 2. That's all you have to do on that one. On this next one, I'm mostly going to examine this picture. On this figure, we're just going to focus on the picture. So right here, we got to examine the two triangles we have. The first triangle right here has two measurements that are 3 and 5, 3 miles and 5 miles. This one has the same stuff, 3 miles and 5 miles. What we need to figure out, though, is this distance compared to this distance. So we'll call it MA compared to MB. We're trying to figure out which one is further from the mall. Is B further from the mall or is A further from the mall? That's what we're trying to figure out. So let's compare back to the angle opposite. So these are the angles opposite. Do I know this angle right here? What is it? How do you know it's 90? There's nothing written in here. The one beside it is 90. How does that compare to this one? Oh, these are a linear pair, and a linear pair always adds to 180. So if I do 180 minus this one right here, I'll also get this one here is 90 degrees. Same kind of process can be done over here. If the outside one is 80, how do I find the one beside it? Subtract from 180. 180 minus 80 is 100. That's a 100-degree angle. So I'm comparing these two angles. Which one's bigger? 100 is bigger. So that means this distance will be longer than this distance. That means MB will be greater than the distance MA. So the question here says, which car is farther from the mall? Well, if MB is farther than MA, which car is farther? Car B is farther from them all. I'd like you to now try out checkpoint number 1. Read it carefully. It shouldn't take long if you understand the concept. All right, checkpoint number 1. It says measure of angle ADB is greater than measure of angle CDB. So ADB is bigger, so I'll put 2 marks, than CDB. ADB is bigger than CDB. Well, compare that to the side across from it. So that's AB, and that's BC over here. Well, if this angle is larger, then this side is longer or bigger. So AB is the longer side. Any questions? All right, that is it.